Introduction.
Divya, today I will show you how to make a delicious cake.
Mother, I would love to see that.
First of all, we took a bowl and put all the ingredients in it to make a paste. Then, we add baking soda in the mixture. Now, it's ready for bake. Now our cake is ready to eat.
It is looking quite good. Mother, can I ask you something?
Yeah, sure.
How are these holes generated in the cake?
Okay, I'll tell you. You know we add baking soda in the mixture?
Yeah, then?
When baking soda is heated, it produces carbon dioxide gas. The bubbles in cake are due to escape of carbon dioxide gas. It makes the cake light and fluffy.
Okay, Mom, I got the answer of my question. But there is some other name of baking soda.
Yes, Divya. Its chemical name is sodium hydrocarbonate.
Mother, I want to know something more about this.
Students, in our everyday life, we use many chemical compounds. To understand these chemicals, we have to know more about their constituent elements. Today, we'll study about the S block elements. Objectives. At the end of this lesson, you will be able to define S block elements, know diagonal relationship, understand group 1 elements, analyze chemical properties and uses of alkali metals, explain properties of lithium, define similarities between lithium and magnesium, analyze compounds of sodium, know about biological importance of sodium and potassium, understand group 2 elements, analyze chemical properties and uses of alkaline earth metals, explain properties of beryllium, analyze compounds of calcium, know about plaster of Paris and cement, know about biological importance of magnesium and calcium. Definition. S block elements. The elements in group 1 and 2 of the periodic table are known as S block elements. Alkali metals. The metals lithium, sodium, potassium, rubidium, caesium and francium, which belong to group 1, are called alkali metals. They react with water to form hydroxides, which are strong bases. Alkaline earth metals. The elements of group 2 are beryllium, magnesium, calcium, strontium, barium and radium. All these elements are also metallic in nature and are known as alkaline earth metals. Diagonal relationship. The elements of S and P block exhibit diagonal relationship. On moving diagonally across the periodic table, the elements show certain similarities. The diagonal relationship is particularly noticeable in the elements of second and third periods of the periodic table. The most important diagonal pairs are lithium and magnesium, beryllium and aluminium, and boron and silicon. Group 1 elements. Electronic configuration. All the alkali metals have one valence electron. The loosely held S electron is the outermost valence shell of these elements and makes them the most electropositive metals. Hence, they are never found in free state in nature. Atomic and ionic radii. With increase in atomic number, the atom becomes larger. The atomic and ionic radii of alkali metals increase on moving down the group. Ionization enthalpy. The ionization enthalpies of the alkali metals are considered low and decrease down the group. Hydration enthalpy. The hydration enthalpies of alkali metal ions decrease with increase in ionic sizes. Physical properties. All the alkali metals are silvery white, soft and light metals. The melting and boiling points of the alkali metals are low indicating weak metallic bonding. The alkali metals and their salts impart characteristic color to an oxidizing flake. Chemical properties of alkali metals. The alkali metals readily react vigorously with halogens to form ionic halides M+, X-. The alkali metals react with water to form hydroxide and dihydrogen. The alkali metals dissolve in liquid ammonia, which are conducting in nature, giving deep blue solutions. The solutions are paramagnetic and on standing slowly liberate hydrogen, resulting in the formation of amide. At about 673 Kelvin, alkali metals react with dihydrogen to form hydrides. All the alkali metal hydrides are ionic solids with high melting points. The alkali metals tarnish in dry air. They form oxides which in turn react with moisture to form hydroxides. They burn vigorously in oxygen to form oxides. The alkali metals are strong reducing agents, lithium being the most and sodium the least powerful. Uses of alkali metals. Alkali metals are widely used as table salt. Cesium atomic clock is used for most accurate time measurement. Lithium is widely used in rechargeable batteries, in cell phones, laptops and pacemaker. Liquid sodium is used as coolant in nuclear reactors. Potassium is used mostly to produce chemicals such as fertilizers for use in agriculture. Lithium is used to make electrochemical cells. General characteristics of the compound of alkali metals. Oxides and hydroxides. On combustion in excess of air, alkali metals form oxides, peroxide and superoxide. These oxides are easily hydrolyzed by water to form the hydroxides. The oxides and peroxides are colorless when pure, but the superoxides are yellow or orange in color. The superoxides are also paramagnetic. Halides. All alkali metal halides have high negative enthalpies of formation. They have high melting point and colorless crystalline structure. They can be prepared by the reaction of the appropriate oxide, hydroxide or carbonate with aqueous hydrohalic acid. Properties of lithium. Lithium is least reactive but the strongest reducing agent among all the alkali metals. Lithium has high polarizing power, due to which it is easily soluble in organic solvents. Lithium has exceptionally small size of atom and ion. Lithium has higher melting point and boiling point than the other alkali metals. Lithium hydrogen carbonate is not obtained in the solid form. Lithium nitrate gives lithium oxide on heating. Points of similarities between lithium and magnesium. Both LiCl and MgCl2 are soluble in ethanol. Both do not form solid hydrogen carbonates. These carbonates decompose easily on heating to form the oxides and CO2. Both react slowly with water. Their oxides and hydroxides are much less soluble and the hydroxides decompose on heating. Both are harder and lighter than other elements in their respective groups. Some important compounds of sodium. Sodium carbonate. Another name of sodium carbonate is washing soda. It is prepared by solvay process. In this process, sodium hydrogen carbonate gets precipitated in the reaction of sodium chloride with ammonium hydrogen carbonate. The equations for the complete process are sodium chloride. Crude sodium chloride, generally obtained by crystallization of brine solution, contains sodium sulfate, calcium chloride, and magnesium chloride as impurities. The crude salt is dissolved in minimum amount of water and filtered to remove insoluble impurities. Hydrogen chloride gas saturates the solution and crystals of pure sodium chloride separated out. Sodium hydroxide. Another name of sodium carbonate is caustic soda. Sodium hydroxide is commercially prepared by the electrolysis of sodium chloride in Kastner-Kellner cell. A brine solution is electrolyzed using a mercury cathode and a carbon anode. Sodium metal discharged at the cathode combines with mercury to form sodium amalgam. The amalgam is treated with water to give sodium hydroxide and hydrogen gas. Sodium hydrogen carbonate. Another name of sodium carbonate is baking soda. It decomposes on heating to generate bubbles of carbon dioxide. It is made by saturating a solution of sodium carbonate with carbon dioxide. The white crystalline powder of NaHCO3, being less soluble, gets separated out. Example. Let's take an example. Why an aqueous solution of sodium carbonate is alkaline, and why sodium is prepared by electrolytic method and not by chemical method. Let's see the solution. Sodium carbonate is a salt of weak acid H2CO3 and strong base NaOH. Therefore, only the anion undergoes hydrolysis giving OH minus ion. Hence, the solution is alkaline. Sodium is highly electropositive and has low E0 value. It is very difficult to add electron to Na plus ion. Hence, it is prepared by electrolytic reduction at cathode. Biological importance of sodium and potassium. Sodium and potassium are essential to all organisms. Their monopositive ions are structure promoters for both polynucleic acids and proteins. Potassium is an important enzyme activator and plays an important role in nerve action and cardiac function. Potassium is required in the cell glucose metabolism and protein synthesis. Sodium is relatively harmless except in excessive amounts. Potassium is moderately toxic to mammals when injected intravenously, otherwise it is harmless. Group 2 elements. Electronic configuration. These elements have 2 electrons in the s orbital of the valence shell. Their general electronic configuration is ns2. These elements are also predominantly ionic. Atomic and ionic radii. They have smaller atomic and ionic radii as compared to those of the corresponding alkali metals in the same periods. Within the group, the atomic and ionic radii increase with increase in atomic number. Ionization enthalpy. They have low ionization enthalpies as compared to those of the corresponding alkali metals in the same periods. Ionization enthalpy decreases as the atomic size increases down the group. Hydration enthalpy. They have larger hydration enthalpy as compared to those of the corresponding alkali metals. The hydration enthalpies of alkaline earth metal ions increase with increase in ionic size down the group. Physical properties. These elements do not impart any color to the flame. They are silvery white, lustrous and relatively soft but harder than the alkali metals. they have high electrical and thermal conductivities. The melting and boiling points of these metals are higher than the corresponding alkali metals due to smaller sizes. Chemical properties of alkaline earth metals. Beryllium and magnesium are kinetically inert to oxygen and water. Magnesium is more electropositive and burns with dazzling brilliance in air. Calcium, strontium and barium are instantly react with air to form the oxide and nitride. They also react with water, even in cold, to form hydroxides. All alkali metals except beryllium combine with hydrogen upon heating to form their hydrides. They are strong reducing agents. They combine with halogen at elevated temperatures, forming their halides. They readily react with acids, liberating dihydrogen. They dissolve in liquid ammonia to give deep blue-black solutions, forming ammoniated ions. Uses of alkaline earth metals. Beryllium is used in manufacturing of metal alloys, adding strength, durability, and temperature stability. Magnesium is a strong and light metal and used to manufacture airplane parts and car engines. Calcium is used in glass, paper, food, pharmaceutical and cosmetic industries. Strontium is used into fireworks and flares. It is also used as a glass additive. Barium is used as a lubricating mud in drill operations and taken as a chalky liquid to silence stomach aches and intestinal problems. General characteristics of the compound of alkaline earth metals. Oxides and hydroxides. The alkaline earth metals burn in oxygen to form the monooxide, which has rock salt structure. The enthalpies of formation of these oxides are quite high. Therefore, they are very stable to heat. Oxides of these elements are ionic in nature, except BeO. All these oxides are basic in nature, except BeO, and react with water to form sparingly soluble hydroxides. The solubility, thermal stability, and the basic character of these hydroxides increase with increasing atomic number. These hydroxides are less basic and less stable than alkali metal hydroxides. Halides. The alkaline earth metal halides are ionic in nature. Beryllium halides are essentially covalent and soluble in organic solvents. Beryllium chloride has a chain structure in the solid state. The tendency to form halide hydrates gradually decreases down the groove. Properties of beryllium. Beryllium oxide and hydroxide are amphoteric in nature. It has high ionization enthalpy and small size. It forms compounds which are largely covalent and get easily hydrolyzed. It does not exhibit coordination number more than 4, as there are only 4 orbitals in its valence shell. It shows diagonal relationship to aluminium. Like aluminium, beryllium is not readily attacked by acids. Beryllium and aluminium ions have strong tendency to form complexes. Chlorides of both are soluble in organic solvents and are strong Lewis acids. Some important compounds of calcium. Calcium oxide. Another name of calcium oxide is quicklime. Calcium oxide is prepared on a commercial scale in a rotary kiln by heating limestone at 1070 to 1270 Kelvin. Calcium oxide is a white amorphous solid. It has a melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moisture and carbon dioxide. calcium hydroxide. Another name of calcium hydroxide is slaked lime. When water is added to quicklime, then slaked lime is obtained. It is a white amorphous powder. It is sparingly soluble in water. The aqueous solution is known as lime water, and a suspension of slaked lime in water is known as milk of lime. Milk of lime reacts with chlorine to form hypochlorite, a constituent of bleaching powder. Plaster of Paris and cement. Plaster of Paris, calcium sulfate. Plaster is a building material used for coating walls and ceilings. It is mixed with water to form a paste which liberates heat and then hardens. Plaster of Paris is produced by heating gypsum to about 150 degrees Celsius. When the dry plaster powder is mixed with water, it reforms into gypsum. If gypsum is heated above 200 degrees Celsius, anhydrite is formed, which will also reform as gypsum if mixed with water. Cement. Cement is a fine powder produced by grinding Portland cement clinker, more than 90%, a limited amount of calcium sulfate, and up to 5% minor constituents. Portland cement clinker is a hydraulic material which shall consist of at least 2/3 by mass of calcium silicates, the remainder consisting of aluminium and iron-containing clinker phases and other compounds. The ratio of CaO to SiO2 shall not be less than 2. The magnesium oxide content shall not exceed 5% by mass. Cement sets when mixed with water by way of a complex series of chemical reactions. The different constituents slowly crystallize, and the interlocking of their crystals gives cement its strength. Gypsum is added to cement to increase the setting time. Biological importance of magnesium and calcium. Magnesium is essential to all organisms. It is an integral part of chlorophyll, the green pigment in plants, responsible for photosynthetic reaction. Its deficiency in plants is characterized by yellowing of leaves. A typical adult human being requires about 200 to 300 mg of magnesium daily. Calcium is also an essential element for all organisms. It forms solid skeletal materials such as bones and acts as trigger for muscular contraction and the release of hormones. Calcium is relatively harmless, however, excess amount may cause deficiencies of other elements such as iron. Did you know? Sodium is a silvery white metal that is soft enough to be cut with a knife at room temperature. Francium was the last element discovered in nature, and it is extremely rare. Scientists predict that only 20 to 30 grams of it exists on Earth. Radium is used in cancer treatment because it conducts radioactive waves. The most abundant element in the universe is hydrogen, which makes up about 3/4 of all matter. Summary. Let's summarize what we have learnt. The metal lithium, sodium, potassium, rubidium, caesium and francium, which belong to group 1, are called alkali metals. The elements of group 2 are beryllium, magnesium, calcium, strontium, barium and radium. All the alkali metals have one valence electron. The loosely held s electron in the outermost valence shell makes them the most electropositive metals. Lithium is least reactive but the strongest reducing agent among all the alkali metals. Potassium is an important enzyme activator and plays an important role in nerve action and cardiac function. The alkaline earth metals have 2 electrons in the s orbital of the valence shell and are predominantly ionic. All alkali metals except beryllium combine with hydrogen upon heating to form their hydrides. Plaster of Paris is mixed with water to form a paste which liberates heat and then hardens. Calcium forms solid skeletal material such as bones and acts as trigger for muscular contraction and the release of hormones.